Okay, in this video we're going to go over solar energy and wind energy. So let's start out with our solar energy section. Now there's basically two types of solar energy. You can use passive solar, which is basically what you do every day. You either open your blinds on your house, or you go sit out in the sun when you're cold, or you go seek shade when you're too hot. And you're just basically using the heat from the sun to warm and cool your house in general, but it's just passive. You're not actively trying to gather that energy and make use of it. What we talk about in this class and what we're focusing on is called active solar. And that is when you're actively concentrating and then converting that solar energy into heat and turning it into electricity. And there's two ways that we're going to discuss that you can do this. That's through the use of a mirror system, solar mirrors, and then also through photovoltaic. So you need to understand those two methods of solar power. Let's start out with talking about mirror systems. Now there's all different types of mirror systems, and this was the first type of solar that we had available to us. And basically what you're doing with a mirror system is you're taking a mirror and you're reflecting the sun's light onto some kind of container that is holding this fluid that contains all these different chemicals that basically allows it to absorb a whole lot of heat. And they can get really hot up to like several hundred degrees. And so that hot fluid then is used and taken somewhere where it's used to heat up against another tube containing water. So the heat of there boils the water gives off steam, the steam turns the turbine, the generator, electricity. So same kind of concept, only what your fuel source is your sun, and that's what's heating up that liquid. Um, Now there's different ways you can do this. You can use parabolic mirror system, which is what you see down in the lower left there, as well as in the center. And there's different types. The one on the lower left is a long line of mirrors, and a parabola basically, parabolic is like this. Okay, so the sun's coming in and reflecting up at some center tube in the center along there, and that tube right here is containing this liquid that's getting heated up, and then that's getting taken into a system where it is taking that heat and using it to boil water. The one in the center there is more like a satellite dish. So that's a whole bunch of mirrors put together, and the liquid containing fluid is being held in a container up at the top, and then that heat is being used to boil water somewhere else. I'm not exactly sure how that system works, but it's using that mirror type system. And then the picture that you see in the lower left is actually one that's just outside Vegas. It's a big project that's still being completed. It's called the Ivanpah Power Tower project. And basically, what you're seeing, those things sticking up, are these towers, and the circles around them are all these mirrors. So you got all these circles of mirrors that are all focusing the sunlight up onto that tower that's containing a whole giant tub of fluid, and that fluid is being heated, and then it's going down and boiling water down there, and there's the turbine and the generator, and then the electricity is being sent off. So here's closer up pictures again. The power tower system on the left, mirrors are in concentric circles, and they're focusing the light onto that tower where the fluid is contained, and then that's used to boil water. In the parabolic mirror system on the right hand side there, you see that it's a long line, and then the tube of fluid goes through the center because they're focusing the sunlight into the center, and then that tube goes off to some station where they are boiling the water to generate the electricity. So here's the steps for a mirror system. You start out with the mirror that focuses the sunlight, and that focused sunlight is heating up the liquid that's either contained in a tube or in a tower, depending on what type of system you're using. The hot liquid then is used to boil water. That boiling water gives off steam that's used to turn the turbine, and the turbine then turns the generator, and that creates your electricity. Um, Now, the other type are photovoltaic cells, and this is probably what you're more used to seeing, especially here in the desert. These are what's going on rooftops, on top of the COD parking garage. These are all photovoltaic cells. Now, what they do is kind of different from the mirrors. They actually gather the sun's heat, and within that panel itself, they're able to generate electricity. So there's no heating up a liquid, taking it into an area, boiling water to turn a generator. They're actually generating their own electricity And I'm going to show you how they do that in a minute, but basically they are exciting an electron and it's popping off of its parent atom and it's being sent across a barrier. And then in order for the parent atom that now has a positive charge to join back up with the electron, or excuse me, it's the other way around. Once that electron is over here, it wants to go back to its parent, and so it's forced to move along a pathway to get over there, and that movement of electrons is what generates the electricity. So the nice thing with photovoltaic cells is there's no turbine needed. You don't need a turbine generator. And that's why they can go straight on top of rooftops and other things, because they're much less maintenance, much easier to deal with, and not nearly as much equipment. The only issue is that the electricity that's generated in photovoltaic cells is called direct current. Okay, the electrons are always moving in one way. Now, in normal electricity and what we create by spinning a generator, excuse me, a turbine, is called alternating current. And so it goes one way and then the other way. And that's because as we spin the magnets around, it's making the electrons go back and forth and back and forth and back and forth. Excuse me, whereas in photovoltaic, it's going around in one unit. So what you end up needing is some kind of a transformer box to switch that DC current into AC current, which is what your house is wired for. Um, these panels are made out of silicon crystals, so they are generated. Silicon is a man-made substance, okay, and it does have some fossil fuels in it that we use. So you do have to consider, the footprint used in generating these. But there's no liquids, no corrosives, and no moving parts, so there's little maintenance. All you really have to do is dust them off once in a while, hose them down, and make sure that there's not a dust layer on there, because that reduces the effectiveness of them. And then every few years you do have to get them changed out because they do wear down after a while. So that's the other idea. Now, depending on what you go with, if you end up going with one of these companies that leases them out, the nice thing with leasing them out is that they take care of all the maintenance. So when they need to be replaced, the company does that for you. On the other hand, if you own the panels yourself, when it comes to getting them replaced, you've got to pay to replace them. At least you don't have to pay for the new installation because they're already anchored down there. You just have to have new ones put in. But again, that's only every like 10 years or so that it has to happen, I think. And again, this is what you see on the tops of houses, garages, etc. Okay, so here's how these photovoltaic systems work. You see in the lower right there, you basically have that pink on top of the blue there. And so that is, it's a sandwich of these different layers of crystals. And the sun comes down, hits that top, that pink layer, and it warms up the atoms in there. And the electrons start moving really fast, they get real excited. And eventually, what happens is they get so warm and so excited that one pops off, and it pops off and it jumps around. Excuse me, that's my phone ringing in the background. Just try and ignore that. It pops off and gets sent across the barrier and can't get back to its its parent atom. So what it has to do is it has to go down and around a circuit where it's generating electricity and then getting back up to its parent atom to join back up with where it was supposed to be. And that's how you create the electricity there. Um, so that's why you get direct electrical generation. Now, again, the thing that you need is a converter box, because you've got to take this direct current and turn it into AC current if you're going to use it directly in your house or send it off to the grid. Now, here's the catch with solar, especially in our area, and I'm not sure if they do this everywhere, but I know for sure in Coachella Valley they do. You have to do something called net metering here. And what that means is if you install solar panels on your roof, you are required to net meter that. And so what it means is that you put those on your roof and you're generating electricity. But Edison won't allow you to keep your own electricity. They won't allow you to just send it straight to your house. What you have to do is have your converter box in there, and then what they make you do is they send the electricity that you generate over to the grid, and they keep track of how much you're making. So meanwhile, you're generating electricity with your solar panels, you're sending that off to the grid, and then whatever electricity you need, your house is pulling back off the grid. And Edison keeps track of all of this, and at the end of the month, they look at how much energy you made and how much energy you used. They find the difference, and then you pay that difference. So say your house used, I don't know, 30 watts of energy. This is really low numbers, but I'm just making up something. 30 watts, and you generated 15 watts during the month. So instead of paying for 30 watts, you're only going to pay for 15 watts. If it went the other way around, say you generated 30 watts of power and your house only used 15 watts of power, then you should be technically paid for the 15 watts that you generated. However, Edison doesn't do that. What they do is they credit you. Okay, they're not ever going to pay you the cash. I'm not sure what's going on there. They don't want to have to pay you the cash, so they'll just send you a bill that says, okay, you have this much credit on your bill. So kind of a crummy deal. The only way that you can get your electricity and keep it within your house yourself is if you live off the grid. If you're not attached to the grid in the valley, which I know a few people who are, but they live way out in the sticks. And then they have to generate all their own electricity. So that's something to keep in mind. Now, pros and cons of solar energy. The sun is definitely a renewable resource, and it's probably inexhaustible as long as it doesn't blow up. So, renewable and inexhaustible. There's no mining waste for the sun, but there is the equipment, so you do have to keep that in mind. Remember the silicon crystals and the mirrors and the liquid that gets heated up and all that. There really are no emissions, even if you're using the mirror systems, because all you're doing is heating up that liquid and boiling water for steam. So no greenhouse gases being given off there except a little bit of water vapor. They're relatively easy to maintain, and as the cost of fossil fuels rise, the cost of solar will decrease, because as we start to run out of oil, the cost is going to go up and up and up, whereas you're not really going to run out of sun. And the other nice thing is you don't need direct sunlight every day. Germany actually produces a ton of solar energy, and they don't have nearly as much sun as we have here down in Southern California. And a lot of countries and states provide rebate programs. So California has a rebate program. You can also often get low interest loans for doing solar. So those are some of the pros. The cons is that the upfront cost for the average consumer is pretty hefty. It's quite a bit more expensive than just sticking with the same old fossil fuels. So that really turns a lot of people off. You've got to have several $1,000s up front to invest in the system. Now, you will make it back relatively quickly, but if you don't have that money to invest up front, it's kind of a hard pill to swallow. If net metering is not available in your area, or if you're living off the grid and you want to keep that energy, their only way to store it is to invest in these gigantic battery systems. And the batteries are huge. So that's another problem, is that, at nighttime, there's no sun shining. So if you don't have some major battery system where you can store energy during the day to use once the sun is down, you're not going to have any way to generate electricity. All right, let's move on to wind energy. Wind energy is captured using wind turbines. We don't say windmills. A lot of people do say that, but a windmill is actually used for either moving water, grinding grain, something like that. So the technical name for them is wind turbines. And the way it works is that the wind pushes the blades around in a circle, and the blades, that spinning front there, is actually directly attached to a turbine, and the turbine spins the generator and you create electricity. So there's no steam driven anything in there. It's all just mechanical, driven by the wind. Now we have a total of 3 wind farms in California. You know, the one in Palm Springs out at Windy Point and around there. There's one up at Tehachapi Pass, and then another one at Altamont Pass near San Francisco. And together, these 3 farms produce about 1.5% of California's energy, which is actually, pretty good considering. There's a link there on the PowerPoint slides. You can take a look at that. These are the inner workings of a wind turbine. This is what it looks like. So you've got the blades on the outside spinning around. As those blades spin, it moves a gear. That gear is attached to the turbine. The turbine spins, and that creates that spins your generator, and then that generates your electricity. And then the wires go down and send the electricity down off to the grid. Now, the drawbacks of wind energy, one of the things is, in order to make it worthwhile to install the turbines, because it's not a small feat by any means, these things are gigantic and it takes a lot of manpower and a lot of time to create these anchor pads and get them up there. In order to make it beneficial, you've got to find a place that's pretty much windy all the time, like out at Windy Point in Palm Springs. If it's only windy, sometimes you're not going to generate enough electricity to compensate for the cost that you did in putting it in. Now, the places that are really, really windy most of the time, people don't generally like to live. And so what happens is you have areas with a high wind that would be great for collecting wind energy, but there aren't people living there. So then you have to transport the electricity that you generated great distances over to where the people are living. And when you transport energy along power lines, you have what's called line loss. And that's because there's resistance in that line as the electricity sends off. So for the further you travel the electricity, excuse me, the further you send electricity, the more you lose to line loss. And so it ends up being inefficient once you get to a certain distance. So you have to keep that in mind. Again, we don't have any way of storing wind energy unless you had some giant battery system. There's no efficient way to store it. So it's either you use it right when you're getting it or you don't use it and it's lost. But the nice thing about wind is if you find the right places, it can be windy all day and all night. So you will have energy being generated at night. Another drawback with wind turbines are birds and bats. They definitely cause issues for both. Birds like to migrate at night because the temperatures are much cooler. And by migrating at night, they can't see those blades spinning around, so they'll often get taken out by them. Remember that our valley lies within a major migratory pathway, which is the Pacific Flyway, so we get a lot of birds and a lot of bats migrating through our area. And when birds fly at night, they use stars for navigating, which are white lights. And we initially started out by putting white lights on top of our wind turbines to alert air traffic to their presence. Well, it turned out that they were also attracting birds. The flashing white lights, birds were flying down toward these white lights and they were getting taken out. So they decided to try something new. And now, if you drive out the 10, you'll see that there are red lights on top of the turbines instead of white lights. They're also trying something else. Instead of having them all blink at whatever times they were blinking, they have them all coordinated to all blink on and off at about the same time. So all the wind turbines have a red light that flashes on at the same time and flashes off. And they're hoping that that really helps the birds to navigate around and not get taken out by them during the daytime, or excuse me, at night. Now, the other thing is during the daytime, you'd think, well, it's not a problem during the daytime. The birds can see the blades. Well, from a distance, it looks like those blades aren't moving that fast, but in reality, they're actually moving very fast. Even though you can watch it move and it looks like it's going like this, the tip of that blade can move at speeds at over 100 miles per hour, 120 miles per hour. When you're a bird flying through there, that's not time to react and get out of the way of that blade. And so birds are often taken out by those blades even during the daytime. And so here's a statistic for you. Between 800 to 1,000 raptors are killed each year out at Altamont Pass alone. And raptors, we're talking the bigger birds, red-tailed hawks, any birds of prey, owls, eagles, kestrels, Harris hawks, any of those guys they're getting taken out by these turbines. And all those guys, except for owls, are pretty much all during the daytime. So you can tell that they don't have that reaction time. Now, another cool thing coming out that I read about a couple years ago was this concept of these um, wind turbines without blades. They're basically these long carbon filaments that kind of look like giant blades of grass. And when the wind blows, it causes them to bend. And this material is made out of something that when it bends, it causes the electrons in there to move and generates a current. So you wouldn't have blades, you wouldn't have wildlife being taken out by them. It also has a very soothing effect on people because I don't know if you've ever sat in a field and watched grass just kind of blow around, but it's got a nice meditative effect. So they're saying that it's beneficial in many ways. The problem is the technology is brand new and we're not really sure how it's being used. So there's a link there. You can see if it's still active. That was the article that I read a couple years ago on these new ideas. So pros and cons of wind energy. The wind is a renewable resource. There's no emissions other than what you're generating by making the turbine. The land under the turbine is relatively untouched, so it could still be used by wildlife or agriculture. So that's kind of nice. Whereas solar panels, if you're putting up a solar panel, the sun's not still hitting the ground, so you have much more impact there. And there are many areas in the US that do have consistent wind throughout the year, so there's a lot of room for growth in this area. The cons of wind energy. They take out birds and bats. The modern turbine upgrades can be pretty significant. And we could really reduce their numbers, but it's very costly to install them, as I said. The potential wind farm areas also need transmission lines because people don't like living in those really windy areas. So you've got a lot of line loss, which costs a lot of money. The wind farms do require hundreds of acres of land, and while the land is still usable in between there, it still has quite a big impact on it. And a lot of times they're not aesthetically pleasing. There's been reports of people who had their house somewhere and they installed a wind turbine and then they actually ended up getting really sick from, you can actually hear them going around. They kind of make a whoosh, whoosh as they're spinning around. And also having the shadow flash across your house, people are getting migraines and all kinds of other issues. If you have a nice view looking out over the mountains, all of a sudden all these wind turbines go up. Probably the property value of your house just went down because you just lost that nice view. So those are other things to consider in the cons to wind energy. Okay, up next we're going to talk geothermal.